So in this example, we've got the measures of three angles of a triangle are in the ratio 2 to 2 to 5. We want to find the measure of each angle. And this is a question that students will ask a lot, so it's really important for you to watch through this. Make sure you understand. If you have to rewatch it, definitely do that. The statement that three numbers are in a ratio C to D to E means that the ratio of the first two numbers, C to D, the ratio of the last two numbers is D to E. And the ratio of the first and last numbers is C to E. So they're all related to one another. So if we've got a ratio 2 to 2 to 5, we already know that two of the angles have the same measure, right? So this is what I'm going to do. I'm actually going to 2 to 2 to 5. So the three angles in a triangle are in a ratio 2 to 2 to 5. I'm going to give myself a little bit more room to write, so I don't have to keep pushing that screen up. So three angles in a triangle are in a ratio 2 to 2 to 5. So we already know that from previous learning, we know that the three angles in a triangle add to 180 degrees. Three sides, 180 degrees. We don't know what their measures are, but we do know that this ratio is in simplest form. Which means that their measures aren't 2 degrees, 2 degrees, 5 degrees, because that doesn't measure up to 180 degrees. But we know that they're a factor of 2 to 2 to 5. So what we can do is we can say 2x to 2x to 5x, right? So let me show you. If I have a ratio of 2 to 4, we know that that reduces 1 to 2. If I have a ratio of 4 to 10, we know that that reduces 2 to 5, right? So if I have a ratio 2 to 4 to 10, I know that that ratio reduces 1 to 2 to 5. Likewise, if I have a ratio 2 to 2 to 5, I can go backwards the other way and say, well, I multiplied this by something. See, I multiplied everything by 2, and that's how I got 2 to 4 to 10. I could have multiplied it by 5. I could have multiplied it by 10. I could have multiplied it by x. So that's what I've done here is I've just taken the ratio and I'd say, well, it's in simplest form, but we don't know what it started as. So we're going to just multiply each part by x. And now I can say that angle 1 plus angle 2 plus angle 3 is 180 degrees. I can say, well, the ratio is 2x to 2x to 5x. If I add those three together, that would be 180 degrees. 9x equals 180. Divide both sides by 9, and we get x equals 20. So we have found our multiple to give us what that ratio originally started at. So 2 times 20 is 40. 2 times 20 again is 40. And 5 times 20 is 100. So that's what the ratio started at. That's the original ratio of the angles. You just simply take the angle measures, 40 degrees to 40 degrees to 100 degrees, and then they reduced it down to 2 to 2 to 5. So the measures of our angles are 40 degrees, and 100 degrees. And if you add those three angles up, you'll see that it measures to be 180 degrees. So this is angle 1, this is angle 2, and this is angle 3. Important to note, because 1 and 2 are equal to each other, angle 3 is the largest angle. So I'm going to finish up this video just talking about what a proportion is. And then in 7.2, the next lesson, we're going to go into what those properties of proportions are. A proportion is an equation. First and foremost, a proportion is an equation. Done. It's a comparison of two ratios. And we know that ratios are another way of saying fractions. So it's a comparison of two fractions. Those two fractions are going to equal each other. So there's your equation is your equal sign. So there's lots of different ways mathematically. This is arithmetically, this is what we do. We use fractions. However, when we're talking about ratios, because we can write ratios with a colon, you could write A to B with a colon is equal to C to D. When three or more ratios are equal, you can also write those as an equation, and that's called an extended proportion. So it's called an extended proportion. So we already kind of looked at this with the 2 to 2 to 5, but now just envision maybe a 3, 2/3 to 2/3 to 5/3. Something like that might be going on. Actually, undo. That's not what would be going on. What would be going on is something like this. 5/10 to 1/2 to 28/56. That's what would be going on. Yeah, that's exactly what would be going on. So we're going to talk about these properties of proportions. I love properties of proportions. There's a few of them, so we're going to need to maybe make note cards and that kind of thing. So have your note cards out ready for the next video. And it's fun arithmetic. So